Welcome to another coding session, continuing with Bangalang. I feel like I say this a lot now, but I'm super happy with where the language has gotten to, and I keep being excited about adding new features, and there's also a lot of cleanup to do, and I would like to do that because I think without that we're going to fall into a lot of holes probably. I think there are a lot of holes in this language. For the use cases that we have tried, it is working, but I think there's a lot of holes. I want to go back to the top of this list here, see if we can knock out a few of these things. I might start with this one because I feel like it's a bit bigger than this. So let's try adding enums. Hopefully after that we have a bit of time to do max and min, and maybe even time to do more after that. I feel like recently we've been doing pretty big tasks that take the whole hour, but let's see if we can knock out a few smaller ones. So, what do we want for enums? I guess we want, to be able to define an enum like this. I want to be able to go bar is my enum.bar, and then I want to be able to say if bar equals my enum.bar, let's print something out, like equal. So that's the main thing, I guess, with enums, just about to declare one. Set one, we want it to be like type safe, so you couldn't. So I'm going to use under the hood, they're going to be 64-bit integers. But if I make a baz that is an i64, this should not be compatible. Actually, I'm going to use u64. That should not be compatible because this should be type enum and this is type integer. We can do some other compatibility tests later, but let's try that. We should also check like this. We shouldn't be able to do this. Let's put baz for now. And this should be valid even though we have foo declared up here. Yeah. This is kind of what I want. So first thing is we need to be able to specify an enum. This is new in our grammar. So I guess it's like a new type. We have struct type, procedure type. So I'm going to add a new enum type. It's enum. And we can't specify the types of the members. It's just like this, I think. So an enum type is just enum, curly brace, one or more identifiers, comma separated, and then closing curly brace. That's it. That's an enum. Later on, we can potentially get a lot more fancy with them. But let's start simple. So they can go on type primary. I mean, I guess they can go wherever this, wherever this can go, which looks like, yeah, what I thought, type primary and right-hand side primary. Type primary is where you would expect it to go, and right-hand side primary is because, for example, here it's on the right-hand side because we're doing a type alias. It could also appear here, right? And this would be the type primary. And this should be valid, actually. Okay, so, right, so that's our grammar updated. So we have one new keyword, enum. So in our tokens, here's our keywords, enum. I think that's everything we need for tokenization. Nothing else is new. parsing, we have these specific parsers for different types. So let's get the struct one and change it to be enum. So I guess the type would be enum in square brackets. First is the enum keyword, opening curly bracket, and then comma separated list of, this is getting an identifier, and this is the type information which does not exist for this. I think that's it. And then we need to add that into the primary. Yeah. So if we find the keyword enum, then we parse an enum type, and it looks like it can go everywhere except left-hand side. So that's all good. I think that's parsing sorted. Type checking, we should get some type checking errors now. Bar is not a member of type enum. Well, first thing here is that this is not a very nice type name. I feel like there should be, where's our, here we go. Yeah, these are the type names. So if I copy the struct one, because it's quite similar, up to here, enum. So it's going to be enum, curly brackets, comma separated member type names. The member type names don't need the type information. So I don't think we even need to concatenate here. It's just this. Yeah, I think that should be it. So does that look better? There we go. Bar is not a member of enum foobar baz, but it is a member, I think you'll find. So we just need to let our type checker know that that is valid. So I guess that's identifier. Yes, here. This is where we're dealing with members of types. So far we have a name and size. So yeah, one downside of the way I'm doing things is that, like, if you put name or size inside this enum, you won't be able to access these, because the way I'm going to do it, I'm just going to say if child node.value equals enum, then we're going to look through the members of the enum, and when we find it, we return. So if we found name in here, then we would skip this. But yeah, so if you have an enum that has a name or size member in it, then you won't be able to do this, unfortunately. But that's okay, not so bad. For member node and child node dot children, I guess we have like found member if member node dot value equals node dot value. That means we've found it, and we can break. We're back. So that's if it's, so I want to fall back to this, right? Oh, and we should give it type information. So actually the type will be this. That's the enum. The enum type will be the type of the thing returned. So maybe we need to move this member found out here, and we'll just go in here if we've not found the member. Then we'll do this. Yeah, I think that makes sense. So now we should not get this error anymore. Yeah, types enum and u64 are not compatible. So that was this test here. That makes sense. We're probably going to get like a crash or something. 2 byte size. We need to specify the byte size, which is 8. I'm going to say it's a 64-bit. So the enum is backed by a 64-bit unsigned integer. That's the thinking. So it's 64-bit, 8 bytes. What is this? Ah, okay. So I feel like we should have maybe an assert here. Do we have one already somewhere? Yeah, like this. Because I think what's happened is it's looking for a type member, it couldn't find one, so then it's going down to here. But really, that should be an error. Yeah, so now we're here. Great. So now this is where we're actually returning a value. So I guess we have something similar to this. And when we find the right member, we need to return something. And I guess it's just the index. You know, in a lot of languages, you can specify, you can manually specify like which number is for which member, but we don't have anything like that now, so they're just 0 indexed integers. So this will be 0, this will be 1, this will be 2. So I think that's it. Return that immediate. I feel like that's going to work except for here. The equals equals. So when we generate an expression, there's all these different, depending on different types, you do it differently. And I think I want to do it the integer way. Because if we do here, there's like this general purpose one, but this is kind of like memory comparison. And it does this nil compare stuff. Like it's not expecting immediates. And I think we are sending immediates. It's definitely an immediate. So so I think we should try and use the integer one. I think that will be a bit better. If we can go, or what's the type? Operand type node type. So for enums, we'll go in here too. And let's just check that that should work. So it's not a signed integer. So we should, so it's going to treat it like an unsigned integer then. Will that work? I don't know if there's like more we need to do. Okay. It said they're equal and they should be equal. I kind of would like to look at the assembly just to confirm that it's doing what I expected it to do. Where are we? Well, this is the end. This is the end of the main thing. Here's our print line. Print line. So there's like an if and a couple of statements up here and another print line. So if we go up to this print line that's above, so this here is the next statement. It seems to be allocating a 64 bits and then assigning a 1 to it. So I guess that's this. So it was happy with this, because I guess this is the same as this. If I go foobar ban, yeah, it says they're not compatible. Okay. What if I do like foobar and bar foo? They're not compatible either. And then if I use the type alias there, then it's happy. Okay, nice. So, and I guess you can omit it, right? You don't need it. So this line here is bar, which is 1. So it's setting a 1. And then it's comparing it with another 1, which is true. So then it's going into the loop and doing a print line. Yeah. So if I put a foo there, we don't get equal. Because it's putting a 1 and then it's comparing it to a 0 now. Because foo is 0. Okay. If I do not equal, we should get equal printed out. Okay, what else to check? Oh yeah, the other thing I wanted to check was this. This should not be allowed. Let me just cut that out. Foo has not been declared. It doesn't need to be. So the types of the identifier, it's hard to say. Okay, so this is obviously foo, right? Foo bar bar. So what assignment are we looking at? We're looking at this line, the right-hand side, and 3 primaries. There's my enum, bar. So it should be bar first, then my enum. There should be 2 primaries. Bar first, then, yeah, the enum type. So what is this? Foo from the declaration. Well, I guess this is the enum type, isn't it? It does have 3 children. These guys. But why am I feel like I should not be going into those. Maybe we need another condition here that's like, if it's a type, then we shouldn't go into the children of the type. It doesn't make sense to do that. I hope that doesn't break anything. Now we're in the same place for generating the identifier. So, so when we generate a primary, maybe we do the same thing, and this primary as well. Okay. He says, with the utmost confidence. So it seems happy again, but it shouldn't be because there's 2 bars. So I feel like that's type checking primary. Yeah, so instead of like going deep again, because type has like a structure to it, can have a structure to it. At the moment we don't do any type checking. So if we're talking about an enum, then we'll go through the members again. And I guess we'll do like a nested loop. But this time we will start, so if we have an index, so we'll start at index plus 1. So for every member, we'll look at the members after it. But that's, I don't want that to go out of bounds. Actually, I'm not sure how that works, but I'm guessing you can't go out of bounds. So this one should be up to the length of children minus 1. So this loop should skip the last member, because if you're at the last member, there's nothing after it to check anyway. This one will always start at the member after this one and continue to the end. And if the values match, then we have an error. Where's an error message? Here we go. So it's like duplicate member found in type, something like that. So that member was found in node, I guess. Duplicate member found in type. We'll give the position where the member was found. Okay. Duplicate member bar found in enum foo bar bar. Okay. So if I take that out, we're golden. Let's reinstate that. It all looks good. Let's just make sure we didn't break anything by changing that type stuff in the primary. I was not 100% that that was a great idea. No, I mean, I think it's a good idea. I'm just not sure if it would break something. Okay, the tests are okay. And OpenGL test seems happy. Okay, so I feel like that's enough for enums right now. I'm pretty happy with that. So let's get this sorted. Max and min members. I guess this is going to be, pretty close in the same sort of code that we're playing in. So we had name size. Guess it'll be max min. We skipped straight into generation, it looks like. So I think this is going to be kind of like a bit of a map, like a switch on child node dot value. So that should be the name of the type. So case and it's all the integers, right? So where can I grab all those? Like, it's like I16, I32, I64. Well, I guess we can say, no, we can't. I was going to say we can use the same results for signed and unsigned, but they definitely have different results. 64, 32, 16, and I put the colon in the wrong place. And then just to be sure, yeah, we put in assert. No, well, these will all return. So if they don't return, no, but we're not in that else. So I'll put that there. And I think I asked Grok to get it for me. So yeah, math.ai, so it's core math. That's just math.typename.min. Hopefully it's not hallucinating. Okay. Let's go math.min. Does that work? What does that say? Requires that its results must be handled. So I guess we need to return actually an immediate So I think it's expecting an int. So if we cast that to int, yeah, I guess it returns a value of the same type. Okay. So then I16, I32. I feel like this is a bit ugly way of doing it. There's probably a better way that's not quite so repetitive. But it's all right. It'll work. And I just realized this is max, and I've put min, so let's go max. Like so. Oh, because the maximum value. Interesting. So maybe I'll do one of these. Because I've been using int everywhere, this type, which is, I think, 64-bit signed. Doesn't say, but I think it's a 64-bit signed. So it could handle all these, but not this, because the max is too big. I guess the min for all the unsigned is 0. Yeah, I mean, I guess I could have just hard-coded 0 there. I guess it's kind of obvious that it should be 0, right? Yeah, the min is always 0. But that's fine. This is fine. Okay. So that's generation. We're going backwards a bit here. Then if we go to the identifier for type checking, back up to here. can say max-min, and we will return. Ah, that's interesting because we need to return. Yeah, I guess the data type of this should be the data type. Yeah, it's kind. I understand it now. I understand why these max and min return the same data type that's passed in, because that ensures that it's able to hold that number. So the child node is the type, right? So I think it should be like that, kind of like we do there. It's the enum. Now it's the number type. Interesting. I do think that could be a switch. Maybe we'll switchify it. I like my switches. So switch node.value, because the reason I thought that is because we can do this here. Case max min, they're the same. Case name, this is also a lot more compact. And case size is this. I think we can just put it on one line like that. And this is the default case. Oh, and we need closing bracket. Yeah, good. Okay, let's do a switch here as well, because I think that'll look nice. So this is case max. Case min, just take these brackets away. Case name. Case size. And it looks like this is the default case. Like so. Is that happy? I think maybe it's also wanting another bracket. Yeah. Okay, so I think that's, is that it? I guess we need to actually add some code that accesses those. So size name, let's do, well, we can't do a vic4. So, that's something actually. If we do vic4, that should fail. So we should, in type checking for max and min, it's a little more complicated. We need to say integer slice.linear search integer types. I guess child node top value. Yeah, child node top value. And if not integer, then bad news. Not a member of type. Yeah, I think that's totally fine. So we should get that now. Yeah, they're not members of those types. But if we change them to like U64 and minimum of like I8. We have to cast them. Ooh, so that's not going to fit. That's not going to fit. So let's say like U6, let's say U8. I actually at least know those numbers. And we'll cast them to I64, because that's what I2A is expecting. So if I know my numbers correctly, this should be 255, and this should be like negative 127 or something. Okay, it's not happy. Playground 224. Can I not zero extend a byte? Interesting. I don't know if, oh, there's zero extending, sign extending a byte. Well, it's memory. Maybe it's the fact that that's an immediate. Huh. Can we not use an immediate there? As a signed extend. This is the only place that's using an immediate with a signed extend. Interesting. Okay, so let's have a look at our conversion code. Convert. So this is the signed extend. And here's the source. Why is that dislocation? The other one's just source. Okay, there's nothing special, I don't think. It should just be dest. Let's just call this like large dest. So maybe in this case we need to make sure the source is in a register. I'm a bit surprised by this. Here we're making, no, that's just destination. I wonder if this would also be an issue. Oh no, these are the ones with floats. That's right, signed extend. So I wonder if it's also zero extend, does it also do that? But let's do it just here for now. So source register location. So copy to register. What do we need to pass in here? Context, source, do the register num. Is it okay if we use the register num? I feel like it could be dangerous. Let's use register number +1 to avoid conflicts. Type node. So the type node, source type node. And then we go source register location. Does that help? That seems to have helped. Copy to register, and then we do a convert like this. Okay, interesting. Let's go to our instruction listing page. Move, signed, extend, register, and then there's like these, yeah, so it's got to be from register or memory. Register or memory. So let's say think we can just, oh, but source is a parameter and it won't let you change it. So because it could be memory also. So let's just say copy to non-immediate. And I think I saw like it's got 0 extend, it's got exactly the same stuff, same limitation. So what this is saying, because it says R and M, it's actually saying specific size too. But because it doesn't also have immediate, it means we can't use immediates on the right-hand side of the operation. So we're copied to a non-immediate. Boom, good. Okay, fix that up. Small improvements as we go. We're 40 minutes in and we've nailed that now. Pretty happy. I've got a bit extra time, so let's scroll down here. There's some things in here that I think are not going to be too hard to tackle. So start thread. This procedure. Now that we have our nice allocators, I thought, why don't we use it instead of doing an mmap call directly? So we should be able to say, we're just allocating 4,096 bytes. That's the idea. From the heap. That should be it. Just need to import OS so we can get the heap. Try that. Well, we don't use threads in that example. In OpenGL we do. But just to be extra sure, actually, we should probably not use the compute shader. So now we'll do it. Now Boomstick will go across multiple threads on the CPU. And that seems happy. Oh, I'm kind of... So this should give back a slice. So I'm actually kind of surprised that that worked. I thought the stack should be .raw. This is the actual pointer to the data. And that pointer is what I wanted to convert to an i64 so I could manipulate the data within it. So now this is a memory address. And then we add, this is like the length. We can do a bunch of stuff in here, like this is the size of an i64. That's the idea, because the two parameters are both 64-bit. I mean, I would like to use U64 more, actually. The instruction pointer is also 64-bit, and all the variables are 64-bit. How does that look? Still works. Okay, that looks a bit nicer. All right. Yeah, that was just a little thing. I think that looks a bit tidier. C-string is alias of byte pointer. We tried to do that a while ago and we got distracted, I think. Let's put that back to using the GPU. So I guess the place to start here is we have C-string in here. So now it's not like a type of its own, it's actually in the globals. Make C-string, which is a pointer to a byte. And I guess we want to check wherever we use C-string and see. I mean, in Bangalang source code, it's fine. It's more Odin code that we want to check. So this is not a thing anymore. It's not its own type. So it won't show up. I don't know if this is a good idea, but I'm thinking maybe I can say like this. Because really what we're saying is if we're talking about a pointer type, then we use immediate. Procedures are implicitly, they are pointers. They're like instruction pointers. And now our C string is actually a pointer to bytes, so it's going to be a pointer. I hope that doesn't break other stuff, which is a phrase that I say frequently. Okay, so now this is more like the regular string. But instead of being a slice of bytes, it is a reference to a byte pointer. Yep, that can all stay. That can all stay. That's all fine. Yes, yes, yes. Okay. C string literal is very good. This is type coercion, so this again is going to be more like what we have. Oh, we can't see it anymore. I thought we might have a copy for some other code. So again, this is like U8, but now it is reference to U8. That means that it's a C string. And this time with B to say that B is a C string. Okay, I think that's all the references to C string. Any string and U8 are not compatible. Yeah, any string should get upgraded now to U. So, is there really nowhere else? I guess not, but where I'm thinking is in types, when we upgrade our types, any string. So I think this is type coercion, right? This is type coercion failing when it shouldn't. So maybe the type coercion changes I made are not good enough. I mean, they look right to me. If A is any string and B is a reference to a U8, okay, it never goes in there. So let's find this error. Is it this one? Yes. So the type node is any string with no children. The expected type node is a reference, and its child is the type U8. So it makes sense that it wouldn't go in here because it doesn't fail. Okay, it's failing somewhere in here. Let's find out where. Okay, so those are not fails. Fail, 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 fail. Fail, 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 fail. Doop, doop. Ooh, might be this. Might be this. The type is different. Oh no, that's there. I feel like that's a JIT. Procedure, procedure, parameters, procedure. Oh, I didn't realize this was going to fail everywhere. But I think I know though. I think I figured it out. I think it's this one. Yeah, we have inner string, and this is reference to a U8. So types should be the same except for here. So values are only going to be there if type equals type, because types are only composed of type nodes and reference nodes don't have values. So I think we can cut this out. And this compatible value types kind of says, hey, we went through, the values were not the same, but we were happy anyway. So in that case, we don't care that the types are different. But in other types, let's check the types are the same. Let's try that. Okay, that seems happy. I honestly have totally forgotten what we were even doing. I got so absorbed in that little detail that I'm like, what were we actually changing? Oh yeah, we made C-string an alias of, and it's working. Okay. Good. So now basically the only purpose of C-string is kind of a semantic one. Same as byte and char, you know, you just use them, same as any alias, I guess. The only point is that it makes more sense semantically. Like a C-string by convention should be null terminated. So anywhere where something is expecting a null terminated string, C-string is probably a good option to use. Right, so do I still have a rogue window open? Let's get rid of that. So that's done. We're at 54, underscore var not saved. I feel like that one's a little more advanced, so I'm going to skip that for now. Basically what I'm saying is that if there is a var that is an underscore, just an underscore, we should just kind of ignore it. I've got examples of that probably in a bunch. Here's one. So this returns 2 values, but I don't care about the first one, so I just put an underscore here. And later on, I could do this again, integer 2, and it's not going to complain, hey, you've redefined this, right? Just doesn't care, just ignores these. So I probably couldn't say cannot be used as a value. Yeah. So it's just like a special character, like a special identifier to say like, hey, just ignore this. I don't care about it. And I'd like to add that to our language. But I think it's going to take a little bit more than 10 minutes. So let's do some simple things like, let's do this context one. I think that's a nice one. So the places we have context is in parsing. So where is probably like statement would have it. Yeah. So I feel like mostly it's going to be just like this. So I just want to like move this over here, cut it out of here, replace, like so. Oh, I didn't think about, like, hopefully that was only in parsing that those changes happened. This looks like it's only parsing, so. Oh yeah, it would have been because it was explicitly said parsing context. So here, yeah, let's say parsing. Can I get back to the other one? Yes, okay. So do a switcheroo with these guys. Is there any parsing that didn't do, that doesn't have a context? Probably none of these take in contexts. Let's just double check to make sure we're all good. Ooh. Ooh. No context. No context. And no context. So can we run that? No, we still have errors. Let's copy that. Like so. That seems happy. That's happy. This should be dummy context apparently. I mean, in parsing, I'm kind of hoping to get rid of this context altogether, to be honest, but it's there for now. So let's do it nicely. No, dummy context. Like so. Close a bunch of these files. Okay. That's done in parsing. Is it generation that it's already done? Yeah, generation, I already did it. So type checking is the last place now to do it. So let's do a replace here. We'll go to the type checking folder. Cut this guy out and put him there. Very nice. Right, so this is quite a different file. Module only takes context. Program does not take context. Statements. Oh, statements was already first. Very nice. Okay. Everything else, I guess, is sorted. I just realized that we have like changed these files like for other changes in this commit. Maybe I should have started a new commit, but it's possible that some of them are not updated. Possible, but it seems unlikely. Everything looks pretty good to me. But I like to be sure. We don't need that. Ooh, see, here's one. That first. Types and utils. Okay. So we're going to have lots of errors. Yeah, resolve types. There is actually a lot of procedures in here. So maybe I'll actually do a search. Yeah, it's probably a good idea to do a search for, I don't know if there are any more, but if I can find comma space, does not exist. Okay. All right, looks like it does not exist as well. Okay, it's only the first. And only the first. Okay, I'm happy now. Now we have to change a bunch of these. That seems happy. So I guess anywhere where there is this, we take it out. Is there a bunch of places where there's like node, comma? There's a lot of node, comma context. Let's change that to context, comma node. That should cover a lot of them, I feel like. But it seems like there's a lot more. So let's just go through and fix all of them up. Hope you don't mind this. I guess this is kind of, I don't know. For me, I need to have things nice. You know? Whoops. I like to have a consistency. I like to have some logic to these kind of things, even though like functionally I'm not making any difference here. It's just to have things the way I like them. And sometimes it's nice just to take the time. to do that. Okay, how are we going here? Still got quite a few errors, it seems like. Got a couple down here. Don't see any more in this file right now. We still have a small progress bar or a small slider bar here, so I guess we still have quite a bit to go, unfortunately. Maybe I can find some. I thought maybe there might be some common ones. Some common cases, but I'm not sure what they might be. Looks like there's a lot of, unique names for these nodes. Oh, that one's already done. For context. Alrighty. Most of those were all good. Procedure context. Is there, or is that the only place that it gets passed? Ah, it's kind of a shame. That's that one. Just keep on keeping on. All right, we must be getting close to the end now. We're at the end. Okay. Whew. Let's get the playground. Looks like it's going well. Run the tests. So I run our 3 different programs. This is done. I think this underscore node is another kind of just a superficial naming thing that I want to change. We're at an hour and 9. I feel like this one will take a little bit of time as well, so maybe we'll leave that. But I think we nailed like 3 things from here and like 2 from up here, so not bad, not bad. The list, I mean, it's still a pretty big list, but it's looking reasonable. VS Code 0. So everything seems great. We have max and min for our integer types. I just realized actually, let me try this in generation. I think, where was it, identifier? I wonder if we can do it with the floats. So it's a casting issue. So again, we can do this guy. Yeah, so we can have minimums for our floating points. And maximums for our floating points. That makes sense, that we should be able to do that. So we should add that to type checking so that it actually lets us do it. Identifier? Here. So not just integer types, numerical types. Which also includes these atomics. Oh, and CInt, CUint. I forgot about all these types. I guess this would be, yeah, CInt and CUint. That's going to be annoying to do. So the assert will catch those. It's a little less annoying to do these atomic ones because they're just atomic versions of the i's. So basically, we can just do this. And I guess we need to do it down here as well. 16, 32, 64. Okay, they should work for those. The problem with these, the CInt and CUint, is that their size is dependent. Oh, but actually, there is c.int, right? Like I can just go c.int. Expected and ordered numeric type to min, invalid type. Okay, that seems to have worked. So that's CInt and CUint. And then this is the max. Okay, so actually that wasn't so bad to add those. So if I go F32 max and min, oh, this is running the tests all around the playground. Oh dear. Ah, because I'm making them an immediate. You can't just make an immediate float. It gets more complicated than that. So it's not identifier, it's primary. And it's generation of the primary. This is what we're interested in, because down the bottom here we handle our floats by making these literals. And that's what we have to do here. So return memory of that literal, and this formatted string goes in here, I believe. So it becomes this massive beast. And this is the F64 version. Wait, no, this shouldn't be string literals. This should be these. F32 and F64 literals. Like that. Does that work? Maybe the issue is actually something else. Playground 328. Whoa. Percent I should be, maybe it should be percent F. Convert. F32 equals blah, blah, blah. Exclamation mark I. Trying to put an F32 in there. It should be, I feel like this should be a float register or memory. I'm not sure really why this has got a heap allocation in it. Oh no, it's before a heap allocation. Yeah, so it's like this line. Oh, how do you, oh, probably because I'm trying to cast this to an I64. Although I do feel like that should work. Okay. Interesting. Yeah, I realize now that like that's probably not going to print out nicely. I just realized this is -1. Probably because we're converting it to a, yeah, assigned. Yeah, so it's actually it's actually not going to print out so well. I guess I didn't even check it before. But this is interesting because F32 minimum did not want to cast. Max does. Max does. So that's like the line above. Yeah, it converts from F32 4. Why does that not do the same? Convert SS to SI. It's like the same operation. And this is the only place that it happens. And in both cases, the source should be like one of these, right? F64 literals. So do we have like, interesting, there's no F64s in here. So it's like something has gone wrong here, actually. Yeah, shouldn't it do this? Oh, wait a minute. Because it's the min. Because it's the min. And I hadn't updated the min yet. That's what it is. So that should be like that. But min. Floats are complicated. Prints out badly. That makes sense. But at least now we have No, we don't. We don't have any F64s. Ah, we still don't, because I actually only used the F32 here. Okay. All right. Just confusing myself. I think I'm going a bit long here, so maybe we'll just finish up. Thanks for stopping by. Have a good one. Ciao for now.